Welcome. So today we're going to start building a real, or start sending commands to a real robot, or at least a robot simulator. And so we have a couple things to cover. It's going to be a very simple robot driver. We're not going to have any sensors at the moment, which obviously is not how you would normally design a robot. While we're at this, before we start though, I want to mention something that we have the first couple of weeks we're covering is going to be basically over Bloom's taxonomy. We're going to be covering the first three layers of this pyramid. That means all the concepts I'm talking about right now, you should remember, first of all, understand. So if I give you a set of instructions, you should be able to explain to me what's happening, and you should be able to apply these tools to your own code. So first couple of weeks, we're actually only working up to this layer. By the end of the semester, we will probably be working up in Create and doing some more higher level thinking on robotics. But keep this in mind. So if you catch yourself looking up how to do something every time you need to write a publisher, or every time you need to write a launch file, you should take note of that, because a lot of this stuff should be second nature, so you can move on to more advanced stuff. All right. I'll stop now. So the first thing we're going to talk about is how do we send a message to the robot. So I have a bunch of stuff open here. I'm going to find one I haven't used. I'll just make a new one. Most robots will be using the twist command. So here I can do ROS2 interface list. Again, this is how I would go about it if I did not know what a twist command is. We actually talked about the twist command earlier in the semester, but if I did not know what the twist command was, this is how I would handle it. And I could pipe this to a file and search for it. I happen to know it's a geometry message, so I look under geometry messages and I have twist. So we could copy that. ROS2 interface show, Control-Shift-V in Bash. Voila. Here is our twist command. So you have a vector linear, which represents your translational movement. Usually, again, every robotic controller is a little bit different, and we'll talk about that. Likewise, your angular, which is going to be your Euler angles for your rotation. Now, keep in mind that what this is saying is this is assuming the robot can move in three directions without rotating. Most robots can't do that. Well, even a helicopter would have trouble. Well, yeah, I guess a helicopter could. So if you had like a drone could move forward and back. Oh, by the way, X is forward and back. Y is up, and Z is to the right. No, Z is up. Sorry, Y is to the right. It's a kind of odd coordinates in ROS2. So X is forward, Y is right, and Z is up. And so if you had a helicopter, it can move forward and back. It could, without rotating, it can move left and right, and it can move up and down. So that's what this vector is representing. Most of the robots we use, in fact, all the robots we use in this class will essentially be able to go forward and backwards. So we just are basically going to be modifying X. X is going to be our forward and backward speed. Angular is the Euler angles for your rotation. So if I was a helicopter, I could rotate around well, I could roll maybe, probably not, but this would be rolling. This would be rolling over the forward vector. Y would be pitch, so moving my nose up and down, and Z would be rotating around the vertical axis, rotating as we would perceive rotating. Once again, our robots are not flying, so we're only really going to be rotating around the Z axis. So that makes it kind of easy, but this is just giving you a heads up what's happening. Now, what are the units for this vector? Well, that gets a little trickier. Again, it's going to be up to the robotic driver. For the simulator, the 0 to 1 represents 0 to 100%. A lot of physical robot drivers will literally be meters per second or centimeters per second, depending on the scale of the robot. Usually the rotation will be similar to the idea of either radians or degrees per second, usually radians per second for the angular. So there is going to be a little bit of exploration with when you get to a new robotic platform. Now, luckily, we can probably, if we really wanted to, using our launch files, we could parameterize this and generalize the launch files so we could run the same code on any robotic platform. We're not going to go quite that advanced, so I'm anticipating a little bit of hard coding, but you could. You could say, okay, my minimum and maximum x's are this value, my minimum and max z rotation is this value, and from that, your script would adjust accordingly. So this is, in fact, how we're going to send commands to a robot. All right, I'm going to kind of work backwards a little bit here, and then we'll go forward. I'll explain why in a moment. So this is the code that we're going to be working through. Again, a lot of this should be very familiar to you. You should be essentially understand how to do your imports from memory now. You may have to look up the exact message type. I understand that, but you should understand your imports by now. You should understand defining your classes. Hopefully you have this put to memory, and just remember the order. You have to initialize, instantiate, spin on the instantiation, destroy the node when it's done, and shut down. So a lot of this boilerplate code should be becoming old hat. Now, one thing I want to warn you guys about, well, we'll get there in a minute, but this is going to be a simple robot that is going to use dead reckoning. Dead reckoning is essentially, say like a pirate. They put a bandana, or they take 10 paces forward, turn to the right, take 5 paces, and X marks the spot. So here we don't have any sensors. We're just going to go forward, rotate, go forward, or go backwards and rotate the other direction. So that's what we're going to do. Now, obviously, this is not a very useful robot. I understand that. But the point here is to showcase how to use the twist and how to interface with the Unity simulator. So we're going to create a publisher. Again, geometry messages, message import twist. So we're going to be using a twist. And we're going to say command velocity. Now, spoiler alert, eventually multiple students will be competing against each other on this Unity simulator. So obviously this is problematic. But we're going to use namespace to get around this so that some of our so that we can send specific command velocities to our own robot. Again, queue size is 10, so that's fine. We have self.timer. We're going to create our timer kind of like we did our dice pub, except this time we're going to fire at 10 hertz. A lot of robotic drivers out there have to be continuously updated, or otherwise they will stop the robot, like real robot drivers. They'll stop the robot out of safety. So the old Pioneers, for example, if you did not continuously send a message, even though it was the same movement command, the robot would stop because they were afraid that something had gone wrong with the controller. And then we're going to have a state 0 and self.state changer, which we'll talk about in a moment. Now, and our callback for our timer is going to be move. Now, one thing that's very, very, very important that you should understand, and this will really set the foundation for when we get into behavior-based robotics. You do not want to do this. I'm going to write pseudocode right now. Okay, go forward, or let me do it this way. while less than 2 seconds, go forward, while less than 2 seconds, turn, etc. You do not want to do that. This is bad. And the reason is eventually you're going to have more than one behavior running on your robot. And while this sequence is occurring, while the robot's trying to do something, something else may need to interrupt it. So in this case, while we could, in this particular case, we could get away with this code, we don't want to have a bunch of loops inside our move. Essentially, what we're going to want to do is have a state machine. For now, we'll talk. With a caveat coming later. So we don't want to ever stop the thread of execution or keep it trapped in here. So basically, as state is equal to 0, we're going to move forward. If state's 1, we're going to turn to the right. And if state is 2, we're going to go backwards. And state's 3, we're going to turn to the left. And then we're going to, whatever we've done, we're going to publish it. I am taking advantage of the fact that when I instantiate twist, all values are 0. So I don't actually have to set all the values. I only have to set my particular values I want. So message.linear.x for forward and backwards. Message.angular.z for rotate right and left. And then we're going to publish that message, whichever one we chose. And what I'm going to do is I'm going to use time as my mechanism to change my state. So if I didn't have these 4 lines here, it would essentially be state 0 forever and just go forward. So I'm going to use time as my catalyst to change my state. Now, obviously, you would not normally use time. What would you use? You would use your sensors. You would use your laser scan values. You would use your blob tracker. You would use your computer vision. You would use your sensors that are detecting the environment, noticing something, detecting a stimuli, and that would be the thing that changes your state. But for now, again, we're keeping it very, very simple. We're just using time. So I'm going to add 0.1 to state changer. By the way, this is a little hackish because I set my timer to be 0.1, and I'm just assuming that, naively assuming that my timer is accurate. That's probably not true. It's going to be close enough, but it's not going to be nearly as accurate as if I use time. But I'm just, again, keeping it simple. So this is going to be the catalyst for my state change. When self.stateChanger is greater than 2, all I'm going to do is increment my state by 1 and subtract 2 from self.stateChanger, so it has to start over, or close to start over, and work its way back up to 2. Again, you would normally not do this in a robotic system. The catalyst for your state change would come from your sensor system. But just for now, we're using time. So that's why, every 2 seconds, I'm going to switch from one state to another, and then my message is going to change. Keep in mind, this is going to be firing a 1/10 of a second. Every 1/10 of a second, move is going to be called, and this function will keep being called. And while state 0, it's going to keep doing the same thing, and that's perfectly fine. This pass-through execution, where it just checks to see what state it is and executes it and goes out and moves on with life, that's what you want. You don't want the execution to get trapped in here in a while loop or a for loop because something else might need to use the robot. So this, again, setting foundations for some behavior-based robotics, this is the mechanism we want to use. Now again, keep in mind that move is going to be repeatedly called. If move was not being repeatedly called, or if this was a thread form, we would probably have to have a while loop here with a sleep around the whole thing. But again, move is going to be continuously called at every 0.1 seconds. So let's save that. Make sure I haven't broken anything. That will not work. All right. We have a warning. That's okay. Now, we do have a couple more issues to cross before we're ready to run this. The next thing is, again, this command velocity looks suspiciously generic, right? And we probably don't want that. Again, this would actually work on your Turtle Sim by default. So we're going to use our namespace, but that means we need to have a launch file. So I have taken the liberty of creating, oh, that's not what I want to do. Creating said launch file. I called mine mover.xml. You can call it whatever you want. And basically I'm going to take in a title, ns title. This is directly from our example in the last movie. And to give it a default test1. You could make this your initials, your name that you're going to use for your class if you wanted to. Then node package class example and an exec simple driver. This is what I added. We'll talk about this in a minute, but simple drive. And then a namespace is going to equal the value of var ns title. And that will put whatever this value is in front of all my topics. So this is, save the file, pause the video if you need to. Okay, so this is our launch file. Again, this is going to go in our class example launch subdirectory along with the one we did last video. Again, if you need to pause the video, please do so. And this is the code. Please make sure you understand what's going on. All right. Now, the last thing, again, this should be coming pretty old hat, but we have to add our file to our setup.py. So we have, it's the wrong setup.py, excuse me. There we go. So I have simple drive class example dot simple drive colon main. Again, don't forget your comma on the previous one. This is the exec I'm going to be using in my launch file. All right, so that's what, again, it does not have to be. This does not have to be the file's name. I just, for simplicity and ease of understanding, I've kept it the same. But this could be whatever you want to call it. And whatever I call it here, this is what I need to have in my mover.xml for exec. All right, so go ahead and build it. Again, if you need to pause the video, go for it. Go ahead and build it, and then it should be runnable, except we don't have a robot to run. So going forward, I will have included in the class some various simulators. And your simulator will probably look a little different than this one, but same idea. Now, before we go too far, there's going to be two different ways you do this. If you're using this at home alone, you're going to be using a NAT connection. So settings, make sure you click on network. You should be using a NAT. And advanced, you want port forwarding. And you want to make sure you have 9090 for host port to guest port. So anything using port 9090 will go from your host machine to your guest machine, the Linux box. Hopefully you have that set up. Now, under Unity Sim in class, I would run this in my computer, but not that one. Let's try this one. At home, you would run ROS2 launch Unity Sim, unitysim.xml. This will run ROS Bridge server, which connects to simulator, and run the topic that will, or the node that will listen for a request to spawn a robot. So we hit enter. We see that it's spawning, and you want to see this message here. This is, once you see server started on port 9090, you are doing good. Then you can open up the executable I've included on Canvas. Hopefully my computer has enough memory to do this. Let's see. There we go. Again, yours is probably going to look a little different than mine. So if you're at home, you're going to use 127.0.0.1.90.90. Again, this is running on your Windows machine. Connect to, and you should see over here, client connected, 1 total, and you want to wait a couple seconds until it says subscribe to Unity Spawn. Now the next part is a little bit awkward, but we need to publish. So ROS2 topic pub, we're going to publish a string to new robot. Now last year I ran it. I used a service. The service is actually it's just as arduous to call, so I simplified it, and so I just have a simple string topic. Feel free to write code that would publish this automatically for you. But if you want to run it from command line, it's ROS2 topic pub / new robot. This is for the Unity simulator. It's a standard messages message string, and then the syntax is double quotes data : you have to have 1 space, single quotes, and then your initials, single quote, double quote. Then at the end, you need to have -1. This says send the message only once. So let me see if I can do this so it splits the screen. So if I hit enter, you'll see a robot appears. Again, your robot, this environment might look a little different for you. This particular environment, the robot's facing away from me, so when it moves forward, it's going to go away from the camera, but it is actually functioning. So once this is here, the next thing we're going to do is we're going to call our launch file we made. So ROS2 launch class example. I called mine mover.xml. You call it whatever you want. And again, a namespace title : equals, I'm going to say bat. So this is going to put bat in front of that command velocity. This is why I don't have to change my code all the time. So if I hit this, the robot should move forward for 2 seconds, rotate for 2 seconds, move back for 2 seconds, and rotate the other direction for 2 seconds. Oh, sorry. So the other thing too is once you spawn the robot, make sure you press space. I have this set up so you have to press space to arm the robot. So let me run that again. It probably will run into a wall now, but so it went forward, it rotated, it went backwards, and then it rotated the other direction. So this is an example of using blind follow, or dead reckoning, dead reckoning. Again, not normally how you would use robotics or how you'd program robotics, but this gives us an understanding of how to use the simulator and how to send commands to move the robot. All right. Please use the simulator I provided and make sure you get your robot to do some movement. Again, keeping in mind that we want to use a state machine over any sort of sequential logic that traps the execution here. All right, thank you. I will see you next time.